Okay, let's do page 4 with a lot of factorials. So first we're going to find n factorial for n equals 0, n equals 1, 2, blah, 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 all the way to 6. So basically I'm going to do 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, and 6 factorial. Okay? So 0 factorial, remember, is defined to be 1. 1 factorial is, of course, 1. And 2 factorial is 2 times 1, so it's just 2. That was an easy one. 3 factorial is 3 times 2 times 1, so it's just 6, right? Okay, now we're starting to get into slightly more difficult ones. Well, since we already figured out what 3 factorial is, 4 factorial is basically 4 times 3 factorial, right? 1, 2, 2 times 3 times 4, that would be 6 times 4 is 24. So if I want 5 factorial, I just multiply 5 times 24. And remember, I had a little bit of trouble remembering that last time, but it's 120, right? I think. Yes. Okay, 6 factorial would be 6 times 120, which would be 600 plus 120, which is 720. Okay, that's far enough, right? Okay. Normally, we're going to use the calculator to do factorials. Occasionally, we'll have some weird factorial problem where we need to do algebra. We'll see those someday. Okay? Now, the important thing is when you do factorials divided by factorials, don't do like an unnecessary amount of work. Don't multiply out 6 factorial and get 720. Just write out, and then after a while, you're not going to write everything out. But at the beginning, you just write out all the factors in the factorial. And then you're like, oh, actually, look, 4 times 3 times 2 times 1, it's on the top and on the bottom, so I can cancel them out. And then I'm left with just 6 times 5, which is just 30. So do you see? I got away with just doing 6 times 5 instead of doing these horrible factorials and getting 720. Now, B, that looks terrible, doesn't it? No, I'm just going to write here 100 factorial is actually equal to 100 times 99 factorial, isn't it? Yeah. And then the 99 factorials cancel out. If you don't remember how to do that, no problem. What you can do is you could write 100 times 99 times 98 times 97, ... And then on the bottom, you write 99 times 98 times 97, ... And now you're going to remember, oh yeah, these cancel out, and I'm left with 100. Okay, last one in this row. 7 factorial divided by 5 factorial times 2 factorial. Same thing as before. If you write everything out, it's pretty easy to see that the 5, 4, 3, 2, 1 in the bottom cancels out with the 5, 4, 3, 2, 1 on top, and you're left with just 7 times 6 and 2 times 1. You could do 6 divided by 2 is 3, and then it would be 3 times 7 is 21. Or you could do 6 times 7 is 42, divide that by 2, and you get 21. So it's 21, right? Okay. Number 3, simplify n factorial divided by n minus 1 factorial. Now remember, n factorial is equal to n times n minus 1 times n minus 2, ... all the way to 2 times 1, right? So actually, n minus 1 factorial is almost the same thing. It just doesn't have the n here, right? So basically, n factorial is equal to n times n minus 1 factorial, right? And the bottom is n minus 1 factorial. So the n minus 1 factorials cancel out. And you're just left with n. Okay? What about n plus 2 factorial divided by n factorial? Similar, because remember, n plus 2 factorial is n plus 2 times 1 less than n plus 2 times 2 less than n plus 2 times 3 less than n plus 2. Okay? So in this case, n plus 2, right, is the biggest number, and then 1 less than n plus 2 is n plus 1, right? So that's why you end up with that. On the bottom, we have n factorial, and n factorial, remember, is the biggest number is n, and then it's multiplied times 1 smaller, and so on all the way to 1. Oh, now look, I can cancel this out, I can cancel this out, and I'm left with n plus 2 times n plus 1, And that's it. That's the answer. Okay. All right, use the formula n chooses r equals n factorial divided by r factorial times n minus 1 factorial to evaluate the following. Okay, we're not using the calculator yet. We're just using our brains. N is 3 and r is 1, so we just need to fill everything in. Not too bad, right? 3 minus 1 factorial. So the top is 3 factorial, which we know is 3 times 2 times 1. We don't need to write the 1. 1 factorial is just 1. We don't need to write that. 3 minus 1 is 2 factorial, and 2 factorial is just 2 times 1. So we write the 2 here. The 2's cancel out. The thing is equal to just 3. Okay? And if you think about Pascal's triangle, remember Pascal's triangle row 3 is 1, 3, 3, 1, right? 1, 3, 3, 1. And if they say r equals 1, what they're talking about is this position here. This is r equals 0. This is r equals 1. This is r equals 2. And this is r equals 3. The r value defines the position in Pascal's triangle row. So if it's 1, it's the second position, which is 3. And that is why this is also equal to 3. Okay? So in addition to this formula helping you figure out what the Pascal's triangle coefficient is, you can do the opposite. You can take the Pascal's triangle coefficients that you memorized and use it to figure out what 3 chooses 1 is. What about 7 chooses 3? Well, most people don't have row 7 of Pascal's triangle memorized, so it's maybe easier to do this. Definitely easier to use a calculator, but we're not going to use the calculator yet. So n factorial is 7 factorial. R factorial is going to be 3 factorial. And n minus r factorial is 7 minus 3 factorial. Okay? If we wrote this out, instead of 7 minus 3, we would put 4 factorial. So we'd have 7 factorial divided by 3 factorial divided by 4 factorial. Okay? When you simplify this, the best thing to do is to cancel out the 7 factorial with the biggest power on the bottom, 4 factorial, and that'll leave the fewest remaining factors. I'll show you what that looks like by writing out all the factors. 7, 5, 4, 3, 2, 1. You don't really need to write the 1. 3, 2, 1. And 4, 3, 2, 1. And put dots in between everything, but I'm not going to right now. Look, 4, 3, 2, 1. That cancels out with this 4, 3, 2, 1. So basically, you just have 7 times 6 times 5, 3 divided by 3 times 2. And if you look carefully, the 6 cancels out with the 3 times 2. So basically it's 7 times 5 and nothing else. So 7 times 5 is 35. See? Even though 7 chooses 3 looks awful, after you cancel out a bunch of stuff, you only need to do 7 times 5, right? Okay, now we're going to use the same formula to do 8 chooses 2 and 8 chooses 6. So let's do that real quick. 8 chooses 2. 8 chooses 2, remember, is 8 factorial divided by 2 factorial times 8 minus 2 factorial, which is 6 factorial. Okay. If we were going to do this, I could write out 8 times 7 times 6 times 5, and then on the bottom, I would 6 times 5 times 5. So do you see how, like, if I cancel out this and this, wouldn't I just end up with 8 times 7 on top? 8 times 7 on top, 2 on the bottom. 8 times 7 is 56. Divided by 2 is, half of that. It's like 28. Okay? It turns out that if you do this one, it's also 28. Okay? And if I write n chooses r equation out, the top is 8 factorial. Did you notice how the r factorial is going to be 6 factorial in this case, and then the n minus r factorial is going to be 8 minus 6, which is 2 factorial? Look, it's the same. They're equivalent. The top is 8 factorial for both. The bottom is 6 factorial, 2 factorial, which is the same thing as 2 factorial, 6 factorial. Okay? So it turns out that the second number here, the r value, repeats. Okay? So if you have a 2 here and a 6 here, it's the same number. If you have a 3 here and a 5 here, it's the same number. What do you know? Remember Pascal's triangle? In Pascal's triangle, remember that a Pascal's triangle row has a symmetry, right? So like this one is the same as this one. This one's the same as this one. This one's the same as this one. So now do you see why, even if you use this formula, you just get the same number again? So like, let's say that this using the notation n chooses r, this would be 6 chooses 1 because it's the second position, so r equals 1. This one would be 6 chooses 5. So when you do 6 chooses 1 and 6 chooses 5, both of them are going to give you 6. If you do 6 chooses 2 or 6 chooses 4, you're going to get 15 in both cases because there's a symmetry, okay? Because look at the denominator. It's 2 factorial, 6 factorial, same thing as 6 factorial, 2 factorial, okay? So you could say, oh, this happens because, the second term of the Pascal's triangle row is the same as the sixth term of the Pascal's triangle row. So it's like, that's basically, what the R value is saying, right? The R value is the position. If you have the left position reflected to the right position, they're both going to give you the same Pascal's triangle coefficient because that's the way Pascal's triangle works. And that's the way the n chooses R formula also works. And they're both the same thing, so this should work that way, right? Okay. Last thing we're going to talk about on this page. So we're going to talk, and we're also going to do a couple of expansions here. Okay, so on the formula booklet, there is this hint for you on how to use the binomial theorem. The binomial theorem is often not understood well by students, okay? Because it has a lot of variables in it, and students don't like variables, okay? Now, basically all this is saying is, if you have this binomial expansion to do, the first term is going to be a to the n. Everybody knows that, and there it is. The second term is going to be the Pascal's triangle coefficient for, this degree. And let's do a specific example just so that we can, see this without variables, because I know that you prefer that. Okay. This is going to be 5. There must be an easy way to change to the eraser. So the Pascal's triangle coefficient for row 5 for r equals 1 is 5. A to the 4, b to the 1, plus 10, a to the 3, b to the 2, and so on, plus ... Do you see how this one matches with this one? And this one is actually matching with this one. This is the second Pascal's triangle coefficient. This is also the second Pascal's triangle coefficient. N minus 1 is 5 minus 1, which is 4. Matches. B is 1. You see? Matches. Okay. So they're not saying anything fancy, that you don't know here. They're saying the first term is the a value to the nth. The second term is, for second Pascal's triangle coefficient, you reduce the power by 1. We know that, right? Now, what is super useful? This one right here, okay? How do we know it's this one? Well, look for the ... dots. The ... dots surround what we call the general term. This is the only useful part of this thing. Everyone else you already know, okay? So this formula can help you find specific terms in the binomial expansion. Let's see how to use it, okay? Let's see. And yeah, this doesn't really say anything that we don't already know. We already know that. Oh, and so on the formula booklet, they just give you this expression. And you need to figure out, oh, this is the general term, and this is the thing I need to sometimes use. You need to recognize it out of the rest of it and ignore the rest, because we don't really need the other parts, okay? And unfortunately, the formula booklet does not give it to you so cut and dried like this, okay? So you need to figure out how you can recognize this part of the binomial expansion theorem and then, copy that out of the formula booklet whenever you need it. Okay, so I took the formula that we need. I copied it out here. It's the general term formula. Okay, just so that I could dive deep in these, I'm not going to do exactly what they tell me to do here. I'm not going to do the first 3 and the last 2 terms of the following. For this one, I'm going to do the third term only. okay? Because that's the whole point of doing the general term formula, that you only want one term. For this one, I'm going to do the second to last term, okay? In Portuguese, the penúltimo term, okay? So basically, all we need to do is we need to fill in the variables with the numbers, with the appropriate numbers. And one thing that's hard for students to understand is the value of R. R is the position in the binomial expansion of this term, okay? The difficult thing is they're not numbered from 1 to 7 or whatever. They're numbered from 0 to 6, okay? So like the first term is called R equals 0, and the last term is called R equals n. So, for example, in this first one, n equals 11, right? The last term would be R equals 11. The first term would be R equals 0. Since the first term is R equals 0, then what would be the third term if we want the third term? It would be 0, 1, 2, right? So it would be R equals 2. So that's kind of hard to figure out. So like if someone says, okay, we want the third term, then you need to say, oh yeah, the third term. So I need to subtract 1 to get the R value. So the R value is 2. Okay? So we want the third term of this binomial expansion. We know, in that case, that R is equal to 2. We, of course, know that the 11 is the n value. So all we need to know now is A and B. Well, remember, the first term is A, and the second term is B. And so now we have everything. All we need to do is fill in the expression now. So I'm just going to rewrite the expression here. This is what you're going to copy out of the formula booklet, just like that. See? We're just copying this out of the formula booklet. Then we're just going to fill everything in. Okay? So let's fill in the n's first, because that's like the easiest thing. The n is the degree of the polynomial. So eraser. I'm using the eraser. Okay. So I'm going to change all the n's to 11. Okay? All right. Now I'm going to change all the r's to R equals 2. Eraser. Okay. And then I'm going to put 2, 2. And then I'm going to change the a's to 1. And then I'm going to change the b's to 2x. And I'm careful to use parentheses. Parentheses to x. Okay. It says I don't need to simplify my answers, but one simple thing I could do is I could get rid of 1 to the 10th power, right? This 11 minus 1 is 10. So 1 to the 10th power is just 1, right? So that just disappears. Okay? So the third term is going to look like that. The 11 chooses 2. I could do that with the calculator by doing 11c2, 2x squared. I could just, simplify that. All right? I could do 4 squared x squared. All right? All right. But it says do not simplify your answer, so I'll just leave that. Okay, now I'm going to do the second to the last term for this one. So this one, we know that the a value is 2x. We know that the b value is negative 3 over x. And we know the n value is 20. The second to the last term would be, let's see, this is the last term is n equals 20. So the second to last term would be r equals 19, right? Did you know that the binomial expansions always have one more term than the degree? So if the degree is 20, that means there's 21 terms in the binomial expansion. The second to the last term would, in that case, be the 20th term, right? Because the total number of terms is 21, so the second to last term would be the 20th term. Now remember, the r value is always 1 less than the actual position. Okay, so instead of 20, it would be r equals 19. Okay? Makes sense, right? The last term is r equals 20, same as the n value. So the second to last term would be r equals 19. So now all we need to do, once again, is first we're just going to copy down the general term formula from the formula booklet. And then we're going to get rid of, or we're going to fill in all the blanks. So in for n, we're going to put the 20 because that's the n value. For the r value, we're going to put 19 because that's the r value for the second to the last term. And the a value is going to be 2x, put parentheses around it. And the b value is going to be negative 3 over x, put parentheses around it. Okay? I'm just going to rewrite it now. So the coefficient, the Pascal's triangle coefficient is 20 chooses 19. The first term, or the a value is 2x to the 20 minus 19th power, which is to the first. I don't need to write the 1 there. And the b value, negative 3 over x in parentheses, to the 19th. And it says not to simplify, so I'm not going to simplify. There's my answer. That is the second to the last term. So you can see it's like we're going to have more practice on the next page, but basically, if they ask you for the 7th term, the 8th term, the 9th term, all you need to do is translate that into the r value, and then you fill in the a value, the b value, the n value, the r value, and then into the general term formula, and that gives you the single term that you were looking for. Very popular for them to ask this on the exam. That's it.